Well, hi there. So in this video, we're going to do some practice related to the GDP deflator, calculating real GDP, and getting up in the business of real GDP per capita. So let's get started. Okay, so the first part up here says, assume the country of Claytonia produces three goods: burritos, xiaolongbao, and latkes, which are three good traditional foods. And in 2010, they made this many of these goods, and this was the price. And in 2020, they made this many of these goods, and this was the price. And the first question it asks us is to calculate their nominal GDP for 2020 and to show our work. So the way we would calculate nominal named GDP is to use the named year's prices, right? So named year's prices. And that's what that nominal is kind of tipping me off to. Nomin, name. Now I have 5 burrito times $3 plus 20 xiaolongbao times $5 plus 5 what are those? 5 latkes times 7. And so that's 15 plus 100 plus 35 equals $150. And so our nominal GDP is $150 in 2020. Now, our real GDP for 2020, this should really tell us that this base year 2010. If you aren't told the base year, you can't do this problem. And so realistically, I need to go back in there and edit that. Base year 2010. And what we say is base year 2010 is base year's prices. Base year's prices. But we're going to use the 2020 levels of output. So we're going to do 5 burritos, but instead of times 3, it's times $1 plus the 20 xiaolongbao times the $3 plus the 5 latkes times the $2. And so that comes out to be 5 plus 60 plus 10 is $75. So the real GDP for 2020 using the 2010 base year prices is half of what actually our nominal GDP is. And it tells us if 2020 was the base year, what's the GDP deflator? So really this should be up there. What's the GDP deflator for 2020? Well, we know that it's the nominal GDP over the real GDP times 100. And that's going to equal to whatever our GDP deflator is. And so we're going to put 150 over 75 times 100. 150 over 75 is 2. And so that's 200. And there are no units, right? No units. That's because it's a deflator. It's an index value. So we would just say 200. Based on our answer in part C, what's the inflation rate from 2010 to 2020? Show your work. So we do new minus old over the old equals a percent change. And that's what we're calculating when we calculated inflation rate is percent change. And so the new value is 200. The old value was 100. And that old value is the base year's GDP deflator, right? So the deflator in the base year is always 100. It has to be. And the new value is 100. And obviously this is times 100 to get a percent change. And so we have all of that times 100. And so that's just equal to a 100% inflation rate. And so we have 200 minus 100 over 100 times 100 is 100% inflation rate. Now, gives us a second data table. Data shows output and prices for 2 countries now, Roggevland and Lavagnaland. We have nominal, deflator, and a population. So calculate real GDP per capita for Roggevland in year 2, show your work. So to get year 2's real GDP per capita, we have to adjust this 990 using the deflator. Now, we know that 990 is the, I had it right. 990 is the nominal over the real times 100 is going to equal to 110. And so that X value is going to be our real GDP. And then we're going to divide that by the population for that year, which is 30. So in order to kind of solve this one, we have to go, therefore, 990 over X is equal to 110 over 100. And here we can kind of see what that ratio then is, right? 11 over 10 is equal to 99 over 90. And so therefore we can say GDP R equals 900. And then divide by 900 divided by 30 is equal to, why am I having a brain fart? 30 which is the real GDP per capita. And so we're just dividing here by 30 because that's our population value for Raghav land. So 900 over 30 is equal to 30. Calculate real GDP per capita for Lavanya land in year 2, show your work. So it's going to be the same process, 840 over x, because it's our nominal over our real times 100, and that's going to equal our deflator of 105. And then therefore, we can say 840 over x is equal to 105 over 100. And this one's a little bit harder, but still not that bad if you notice that this then would be 800, right? Because 840 over 800 is equal to 105 over 100. And so therefore, we can say GDPR equals 800. And then we take 800 and divide that by 10, which is the population, and we get 80. Right? Because the population over here is 10. And so we would say that real GDP per capita for Lavanya land is higher than Raghav land. Sorry about that, Raghav. Both countries continue to produce capital and consumer goods and maintain full employment output, but Lavanya land decides to allocate more resources to the production of capital goods, while Raghav land produces consumer goods. As a result, what's the effect on the long-run economic growth rate of Lavanya land relative to Raghav land? So L land, slower growth, we can say, than our land, because faster, faster growth than Raghav land, because more capital, therefore increased productivity. And that is actually our shifter of long-run growth. And so long-run productivity is the real key for economic growth, right? When we're talking about long-run economic growth rates, we're saying, are we more productive? But also you could just say there's more resources, and that's increased growth. But it's really the investment in this new capital that makes the big difference here. So hopefully this helped you making sense of kind of switching back and forth to use the GDP deflator to find the real GDP, to find the real GDP per capita, also kind of using the GDP deflator to find the inflation rate, another important kind of characteristic of working with GDP. I'll see you next time.